Here's your lesson on compound interest. So compound interest is when you calculate interest, it gets added back into your account. And then when you do interest again, you calculate interest on the new amount. So every time you do that process where you calculate interest, add it into your account, and now you have a new amount, and you base the interest on the new amount, that process is called compounding. Now, there's a formula to do this. Now, obviously, if you owe money, that's bad. But if you are earning money, we do want to earn money with compound interest, so you earn more money. So there's a formula to figure this out. And this is the formula. And then we'll write down what the letters mean. So it's P times 1 plus R divided by N to the exponent NT. A is the end amount. P is the principal amount, which is the beginning amount. Can I spell beginning? Is that how you spell it? Anyways, the beginning amount. R is the interest rate as a decimal. N is the number of times compounding per year. The more times you compound, the more you get, or the more you owe. And T is the number of years. Okay, here we go. You ready? So we're going to use this formula to answer these stories. Dave invests $300 in an account with a 5% interest rate. If he makes no other deposits or withdrawals, find his account balance after 15 years. If the interest is compounded with the following frequency, semi-annually or monthly. So break it down. The initial amount is $300. The interest rate is 5%, and as a decimal, that's 0.05. By using this formula, we divide by how many times per year. Semi-annually means two times a year you're compounding. So for N, you plug in 2, and there are 2 places for that. And then T is the number of years, which is 15. So there it is. And that formula will then give you the end amount. Otherwise, if you didn't have a formula, it would be very long and tedious. So that amount is $629.27. There it is. That's a calculator question. Now, how would that change if it's monthly? Would you expect this to be more or less if you're compounding it more often? So instead of twice a year, monthly means 12 times a year. So everything else would be the same except for N. So we change that to 12 and then put that in your calculator. So you'd expect it to be a little bit more, and it is. The amount in your account would be $634.11. So the more times you compound, the more that's going to be in your account. Number 2, if $2,500 is deposited in a savings account earning 8% annual interest, how much will be in the account at the end of 25 years? So these are the numbers we're going to use in our formula. And then it's compounded with these. Now, quarterly means 4 times a year. Daily would mean 365 times a year. I know there's one year that has more days, but we're going to use 365 and then use the formula. So the formula in this case, again, is how much are we starting with? 2,500. 1 plus the interest rate, which is 0.08, divided by how many times per year, which is 4. We write that down here and here, and then multiply 4 times how many years, which is 25. All right, use your calculator, and you would get the answer $18,111.62. Pretty good, right? I think it's pretty good. You started with 2,500. That's what you end up with. Pretty good investment. Would you expect this amount to be greater or less than that? So the more times you compound, so this is 4 times a year, 365. This will give you more money at the end. So let's see if that's true or not. So again, 2,500. Everything else is written the same, except here is 365. right? There it is. Put that in your calculator, and it is a little more. You get $18,468.58. Done. Number 3. When Amelia turned 6, her grandparents opened a college savings account for her with an initial deposit of $500. The account earns 3.2% interest compounded bi-monthly. So bi-monthly means twice a month. So 12 months, that means N is going to equal 24, right? So bi-monthly, twice a month. So how many times is that being compounded every year? So it's 24. What's the initial amount that goes in? So it's 500. The interest rate is 0.032. So you write it as a decimal. Divided by 24. Write it down here and here. Times, well, at the age of 18. So 6 to 18, how many years went by? So you can see that's 12 years. Put that in your calculator, and how much money she'd have? She's going to be so rich. $733.88. Better than nothing, right? Turn the page. Number 4. Suppose a savings account offers 0.4% interest compounded semi-annually. So that's 2 interest rate as a debt. Be careful here, right? You got to move it twice. So that's 0.004. If Samantha opens an account with $750, how much will she have earned in 10 years? All right. So 750, 1 plus the interest rate, 0.004, divided by 2. 2 times 10. How much money is left there? And just in interest. So this is $780.58. But the question wasn't how much she has in her account. The question is how much interest. So then we have to go 780.58 subtract 750. So what's left is the interest. So how much did she gain in interest? And the answer is $30.58. Number 5. In number 5, Carter deposited $1,000 in 1990. That earned 2 3/8. Well, that's tricky. Percent. Why did they do that to me? So, how do you change that to a decimal? So, 3/8 means 0.375, just so you know. So 2 3/8 would be 2 point that. That's what it'd be like as a percent, and then you move the decimal. So that's 0.02375. How many times is it compounded? Compounded quarterly. So N is equal to 4. That's quarters. 4 quarters make $1. And then 1990 to 2025, that's 25 plus 10, that's 35 years. And then use your calculator. How much is there? So that's what you would type in. And you get $2,290.55 from the initial investment. All right. Now's the last part. Continuous compound interest takes us back to the formula we did before, which is this one. So when it's continuously compounding, that's the formula we used before that we're going to use again, but just with money. So if $800 is invested and it's 6% interest rate compounded continuously, that's the key word to know. It's this formula. So we started with $800. E, the interest rate is a decimal. And how much time has gone by? 20 years. Use your calculator. And how much money is that? That's $2,656.09. Number 7, find the balance of an account after 5 years, $1,200 initially invested. It's 12.5% and it's compounded continuously. So the base is E. 12.5% is 0.125. And how many years? 5 years. That's it. Type that in your calculator and you get $2,241.90. All right, number 8, last one. Carla is investing $1,500 in a new 30-year retirement account. Determine which of the interest rates and compounding periods shown to the left would be your best investment. So we have 2 options here. So we'll do option A and we'll do option B and see how much will give us more money. In option A, we start with, and it's compounded monthly. So $1,500. If it's compounded monthly, then this is the formula we use. The interest rate is 5.5. So move the decimal. Compounded monthly means 12 times a year. And then it's for 30 years. So there's option A. Put that in your calculator. And you get $7,781.08. Option B is compounded continuously, but with a worse interest rate. So compounded continuously, we start with 1,500, but now it's E to the exponent 0.027, again times 30. So now how much money will they be after 30 years? And it's $3,371.86. Now obviously which option's better? Right? The one that gives you more, and it's over. All right. I think that's it for the lesson, right? Homework next. Mr. G Math over and out. Till next time.